Hi dears, welcome. Sorry, yesterday I said I'll put a live, but I couldn't due to some work. So this is what I have uploaded in the shorts, which I have mentioned in the last live class. So I guess you went through these formulas that is already given in the textbook. So if you want, you can take the screenshot, or I have uploaded it in the YouTube shorts in my channel. So you can go through whenever you are free. And these are the formulas. Those formulas in page number 243 and 244. So in page 243 it is given as integrals of some particular functions. It is given there, and on the next page. So I have 6 formulas. These we will use so far we have devised the questions that were like we can able to simplify using the trigonometric ratios or the algebraic identities, and also somewhere like adding and subtracting the terms, and we were able to use the substitution method. But in these kind of question, if you see, substitution method also it did not work out, and trigonometric ratios whatever you use, like for the immediate thing you can't simplify. That is the main thing here. So to simplify or to integrate it, we are using those 6 formulas. If you have the integrals in these forms, you can integrate. So that is how we are going to convert the given question, that is you are going to rearrange, because if you want to use these formulas, the numerator should be 1. Okay, that is 1 into dx. And here if you see, like you have few terms in the numerator, like for those questions you will try the substitution method. You will convert in the given question, like you have x, in terms of x you will be converting to t and dt form. Then you will use this formula and you will integrate. So that is what the thing is. So exercise 7.4. So I guess you will have the textbooks with you. Oh, no problem. I will be writing the question. Exercise 7.4. If you cannot see, please tell me. Question number 1. Integral I equal to 3x square by x power 6 plus 1 dx. As I said, if you want to use a formula, the numerator should be 1. If you check in the numerator, the degree is 2. And if you check in the denominator, the degree is 6. Can we rearrange the x power 6 in like power, the whole power? And if you see all the formulas, like if you check, it is in power 2. That is power 2 for all the formulas. So we are going to express this x power 6 as power 2. And we know power, the whole power will be multiplying, right? 2 into 3s are 6. So we are rewriting this, just we are rewriting the given question. So x power 3, the whole power 2 plus 1. So just we have rearranged the given question, that is only one term, x power 6 we have rearranged as x power 3 the whole power 2. Now the substitution part. So which part we can take? We can just take x power 3 alone, because in denominator we should have it as x square plus a square or a square plus x square, whatever it is. So now only like power 2 we need in the formula. So just take this part alone. So let x cube equal to t. Now as usual, what we are going to do? Differentiate both sides with respect to x. So t will be dt by dx. Already we have 3x square in the numerator part, so no need to take the constants to the right side as we do in the previous questions. So take dx to the left side. So we have 3x square dx equal to dt. So that is what, like we have rearranged the terms in terms of t, and now we have differentiated. So 3x square dx can be written as dt by x cube we have taken it as t, power 2 you have, so t square. So either you can write it as 1 or 1 square. Okay, like 1 we don't need to think much, yeah? So it is 1 square. Now you have to write the formula, that is, it is of the form integral dx by x square plus a square. Like we had already the formula, right? Dx by 1 plus x square is tan inverse of x. The same thing, in place of 1 you have a square, that's all. So the formula will be tan inverse of x by a plus c. So for 1 it is like by 1 you can write. For any other number you have to write it as by a. In place of x you have t, in place of a you have 1. Because it is x by a, so it should be t by 1. So this can be written as tan inverse of t by 1 plus c. T by 1 anyway it will become t, and replace t in terms of x. So that will be your final answer. So tan inverse of x cube plus c. This is the required answer. Any doubt on this? Any doubt? Please post if you have any doubt. Now, question number 2. Question number 2, I equal to integral 1 by root of 1 plus 4x square dx. Here, one more point we have to take care is, like if you see the coefficient of x in all the formulas, either it will be plus 1 or minus 1. If you check here, it is plus 1, minus 1, plus 1, plus 1, minus 1, plus 1. The coefficient of x square should be plus or minus 1. Then only you can use the formula. Constants we need not to worry about that. But for the coefficient of x square, you should check whether it is plus 1 or minus 1. Either if you have plus or minus, we can use the formula accordingly. But here if you see, the coefficient of x square is not plus or minus 1. What is the number you have? 4. So whatever the number you have, take that number as common so that we can eliminate, or we can use the formula so that it can be taken outside. Now, since x square is positive, I am writing it first. What is the coefficient we have here? 4. So take that as common. So that will be x square. Or in simple terms, if you want to understand, divide this terms alone by the coefficient of x square. That also will be easy. So you have x square plus 1 by x power, 1 by 4. Because we have only 1. If we need to take 4, then we don't have. So we are writing as 1 by 4. And since it is into, we can split the root as root 4 into root of x square plus 1 by 4 dx, isn't it? Now, as 1 by root 4 is constant, I am taking out of the integration, and we know root 4 is 2. So this can be rewritten as 1 by 2, because root 4 is 2, dx by root of x square plus 1 by 4 can be written as 1 by 2 the whole square, because if you square you will get it as 1 by 4. And again, this is of the form, you have to write that. So integral dx by root of x square plus a square. Do you remember the formula? Can anyone post the formula here? So log of x plus root of x square plus a square plus c. So I guess you remember. So the formulas which I have posted yesterday for your reference, it is also in the textbook. So you have these formulas, isn't it? So here you have root of x square plus a square is log of x plus root of x square plus a square. So that is what applied here. So you need to write which formula you are going to apply, or which form you have converted. Now in place of x you have x, in place of a you have 1 by 2. So to write the answer, you will be writing it as I equal to 1 by 2 already we have, log of x, in place of x we have x only, like Previous question we had t as we have used the substitution method. Here you have x as it is plus root of x square plus a is 1 by 2. So a square is 1 by 4 plus c. Either you can leave like this or you can take the LCM. So 1 by 2 log x plus root of 4x square plus 1 by 4 plus c. So either you take the LCM or not, like you can leave in the previous step also. Is it clear? Can we move on to the next question? Question number 3. Integral dx by 2 minus x the whole square plus 1 the whole square root. So denominator we have square root. Okay. We can use directly, we can do the substitution part, or we can use the substitution method. Sorry, directly you can integrate, or you can use the substitution part. So now let 2 minus x equal to, don't take the power because we need power 2 in the denominator for using the formula. So just take 2 minus x as t. That will be like when you differentiate, you will get minus 1 because with respect to x only we are differentiating. In question we don't have the negative, so take that negative to the left side. So it will be dx equal to minus dt. Now substitute whatever the terms you have taken. So I equal to, in place of dx it is minus, so I have written that minus outside, dt by root of 2 minus x is t, so it is t power 2. 1 I can rewrite it as 1 square. So what is the formula? Integral dx by, it is of the form integral dx by x square plus a square. Just now we have used log of x plus root of x square plus a square plus c. So this is the formula we are going to use. In place of x you have t, in place of a you have 1. Now that becomes minus you have outside. So minus log t plus root of, and you have t square plus 1 square plus c. Now replace in terms of x. So minus log, in place of t it is 2 minus x plus root of 2 minus x the whole square plus 1 square plus c. This is the required answer. Any doubt? Any doubt? Do you want me to repeat any questions? Or if you have any doubt, please post in the chat box. Question number 4. Integral 9 root of 9 minus 25x square. Like how we have solved the second question, the same process we are going to apply. And we have 25 as the coefficient of x square. Minus we don't need to worry. So just take 25 as common. So this can be written as 9 by 25. This can be written as x square. Now like how we have taken 1 by root 4 outside as 1 by 2. Similarly 1 by root 25 can be written as 1 by 5 integral dx by root of 9 3 square, isn't it? So 5, so 3 by 5 the whole square minus x square. Now you have to write which formula or which format it is. So integral dx by root of a square minus x square. Formula is sine inverse of x by a plus c. So this is the formula. So we have already learnt the 1 by root of a square minus, 1 minus x square is sine inverse x, and here instead of 1 you might get any constants. So it is 1 by root of a square minus x square is sine inverse of x by a plus c. In place of x you have as it is x, and in place of a you have 3 by 5. And since a is in denominator, when you substitute it will be of the form 1 by 3 by 5. So we can write it in reciprocals as 1 by 5. You already have it outside. When we use the formula, the reciprocal of 3 by 5 is 5 by 3 into x plus c. This is the required answer. Any doubt? Can we move on to the next question? Can you move on to the next question? Question number 5. Integral 3x by 1 plus 2x power 4 dx. That will take it as I as it is. Now we are going to rearrange the term. That is, we are going to rewrite this x power 4 as x square the whole square. So 3x by, I'm just rewriting this, since everything is plus, I'm going to write x as first. And one more thing, we have 2 here. We'll take that as common. So when you take 2 as common, we'll have only x power 4. I'm rearranging that as x square the whole square plus 1 by 2. Just I have taken 2 as common as I have 2x power 4 here. And 3 we have it outside. Take it out of the integral. So that will become 3 by 2 integral x by x square the whole square plus 1 by 2 dx. Now you can use the substitution method. Like we can take x square like in the previous sum. Let x square equal to t. When you differentiate both sides with respect to x, you get it as 2x equal to dt by dx. And x into dx only we have. You don't have 2 terms. So take 2 to the right side. So it will become dt by 2. The question now becomes 3 by 2 already you have. You have 1 by 2 layer that I am taking outside of the integral. So that will be 3 by 2 into 1 by 2. Integral x dx is dt by 2. That 1 by 2 I have written already out. So simply it will be dt. X square is t. Power 2 you have. 1 by 2. Since 2 is not a perfect square, can we rewrite it as 1 by root 2 the whole square? Because root 2 square will get it as 2. So this will become 3 by 4 because 2 into 2. Integral dt by t square plus 1 by root 2 the whole square. You need to mention in what form it is. So this is of the form integral dx by x square plus a square. We know that 1 by a tan inverse of x by a plus c. This is the required formula. And now when we apply, in place of x you have t, in place of a you have 1 by root 2. Since it is a is in the denominator, reciprocal of 1 by 2, that is like instead of writing 1 by root 2, you can write the reciprocal. Here also the same thing. So it is already have 3 by 4 and this will become root 2 by 1 tan inverse of root 2 t by 1. Like you need no need to mention that as it is by 1, and replace t as whatever we have taken, x square. And now this 4 can be written as 2 into 2 and 1 2 you can write it as root 2 into root 2 tan inverse root 2 x square plus c. So 1 root 2 gets cancelled. So I have 3 by 2 root 2 tan inverse root 2 x square plus c. This is the required answer. Any doubt? Question number 6. Integral x square by 1 minus x power 6 dx. We'll rearrange as it like the previous question. So I am rearranging that x power 6 as x cube the whole square. Now take x cube as t. So let x cube equal to t. When you differentiate both sides with respect to x, you will get it as 3x square equal to dt by dx. Since we don't have 3 here, so that can be written as x square dx is equal to dt by 3. Now, replacing x square dx as dt by 3, and since it is constant, I am taking that 1 by 3 outside of the integral. Then this will become x square dx will become dt by 3. So that 1 by 3 we have written outside. 1 minus x cube we have taken it as t, we have power 2. So this 1 also we can write it as 1 square. So now what is the formula we can use? What is the formula we can use? Integral dx by a square minus x square. So that formula, what is that formula? 1 by 2a log of a plus x by a minus x plus c. So this is the formula for integral dx by a square minus x square. In place of a you have 1, in place of t you have x, in place of x you have t. So this can be written as 1 by 3, already we have 1 by 2 into 1 is 2 log 1 plus t by 1 minus t plus c. Anyway, we can't cancel here. So 3 2s are 6 log of, replacing t in terms of x, that is x cube. So log of 1 plus x cube by 1 minus x cube plus c. This is the required answer. Any doubt in this? Do you want me to repeat anything? Okay. Question number 7. Integral x minus 1 by root of x square minus 1 dx. That we take as I as always. Now try to split the numerator. So I can write it as integral x by root of x square minus 1 minus in between integral dx by root of x square minus 1. For this question, if you see that we can straight away use the formula. So this I am writing it as I1 minus I2 so that it is easy for us to work out. So for I1, you have to use the substitution method. So x by root of x square minus 1. Straight away also you can take the denominator as t. So let x square minus 1 equal to t. When you differentiate 2x equal to dt by dx, so that will become x dx. X dx is equal to dt by 2. So this will be written as, so I1 equal to dt by 2. So that 1, 2, like I am writing outside of the integration. So dt by root t. That we can take it to the numerator as t power minus half. Now you have to use the power rule. So t power minus half already you have plus 1. So you have minus half plus 1. When you take the LCM, it will be half, power half, denominator also power half, like denominator also you have half. So since it is in fraction in the denominator, you will take the reciprocal. So the integration is 1 by 2 into 2 root t or 2 into t power half. Anyway, both means the same. 2 gets cancelled. Replace t as in terms of x. So it is x square minus 1. So this is for I1. Similarly, for I2, it is straight away you can use the formulas. It is of the form x square minus a square. So you have it as integral dx by root of x square minus a square. What is the formula? Log x plus root of x square minus a square plus c. This is the formula. And now I2 answer will be log x plus root of x square minus 1 plus c. And we'll substitute here. Let us take this as the first equation. Substitute I1 and I2 value here. So I will become, I1 value is, what is I1 value? Root of x square minus 1 plus in between. No, minus. You have minus in between. Log of I2 value is x plus root of x square minus 1. So here if you see, like you can write it as C1 C2 for I1 I2. You can write it as C1 plus C2. As a whole, you can replace C1 plus C2 as capital C. So root of x square minus 1 minus log of x plus root of x square minus 1 plus capital C, where capital C is C1 plus C2, or we are rewriting that C1 plus C2 as C. In place of C1 plus C2, you are substituting a whole variable as capital C. Is it clear? Is it clear? Any doubt? Question number 8. Question number 8. Integral x square by x root of x power 6 plus a power 6 dx. Just here straight away you can rearrange. So integral x square by root of x cube the whole power 2, a cube the whole power 2, because we should have as whole power. Now take x cube as t. So let x cube equal to t. Now differentiate both sides with respect to x. We get 3x square equal to dt by dx. Since we don't have 3 in the given question, take it to the right side. So x square dx is dt by 3. You can write that 1 by 3 outside. So 1 by 3 integral x square dx is dt by 3. That 1 by 3 we have taken out of the integral. So it is dt by root of x cube is t. So t square. A cube you can write it as it is. So in place of x you have t. In place of a you have a cube. Okay. Write the formula. That is integral dx by root of x square plus a square. Formula is log of x plus root of x square plus a square plus c. This is the formula. Now in place of x we have t. 1 by 3 as it is, log t plus root of t square plus, in place of 8 is a cube, so square will be t square plus a power 6 plus c. And now replacing t in terms of x, it is 1 by 3 log of x cube plus already power 2 you have. So x cube the whole power 2 will be x power 6 plus a power 6 plus c. This is the required answer. Question number 9. Integral secant square x by root of tan square x plus 4. So here also you can straight away use the substitution method. Which term we can take it as t? It is very obvious, right? So we can take tan x as t. When you differentiate on both sides with respect to x, you will get it as secant square x, because tan x differentiation is secant square x, and the denominator dx I am like straight away writing here as into dx equal to dt. Now replace, in place of secant square x dx, it is dt by root of, in place of tan it is t, we have power 2, and 4 we can write it as 2 square. Now you have it as in the form of integral dx by root of x square plus a square. Okay, so now again the formula log of x plus root of x square plus a square plus c. So this is the formula we can apply here. and in place of x we have t, in place of a you have 2. This will become log of t plus root of t square plus 2 square plus c. Replacing t in terms of x, you will get it as tan. So tan x plus tan square x plus 4, because 2 square is 4, plus c. This is the required answer. Is it clear? Can you move on to the next question? Okay. Question number 10. So question number 10, we have it in quadratic equation. I guess you know or you are familiar with completing the square method, isn't it? Do you all remember completing the square method? So using that completing the square method, you have to simplify. So I'll just explain if you don't know, or just like a refreshment. So completing the square method, just write only the equation part. Write it as consider what we are going to take, x square plus 2x plus t, 2. Whatever the equation, that alone write it as consider. Write that equation part alone. Now, the first step will be check the coefficient of x square. Always the first step will be checking the coefficient of x square. It should be always plus 1. If it is not plus 1, you need to take that number as common, like how we did in question number 2 and 4. Like how we have taken that 9, 25 or 4 as common. In the same way, whatever the coefficient of x square, that you have to take. So always the first step will be checking the coefficient of x square. It should be always plus 1. And if you check here, it is plus 1. So already step 1 is completed. Step 2, take the x part, that is take the coefficient of x part. Whatever the number you have, divided by 2. Just have it as a fraction, no problem. We don't need the exact answer. Whatever the coefficient of x divided by 2. Now you have the coefficient of x is 2. Just divided by 2, you will get the answer as 1. Or if it is 3, then it is 3 by 2 is the answer. So whatever the answer, you can get it as a fraction, or you can, like, you will simplify and get the answer. Whatever the answer, you are going to square it. So that these things will be done in the rough column. So what is the square of the answer? 1 square. Or like in this form itself you write. First step, coefficient of x square should be plus 1. Second step, take the coefficient of x divided by 2. Third step, write these two as it is. X square plus, always write the x square in x term. You got the answer here, right? As we have squared it earlier. You need to add and subtract that term in this step. Okay? You need to add and subtract that term in this step. So that will become plus 1 square minus 1 square, plus we can combine with x square x and this, minus with the constant whatever you have. So minus 1 square plus constant whatever you have here, you are going to write as it is. Now this will become as x square plus 2ab plus b square, or x square minus, like either you can remember in a and b form or x and y form. So a square plus 2ab plus b square form, or x square plus 2xy plus y square form, like xy or ab, whatever the form you get. Or in the form we'll get it as x square minus 2xy plus 6y, because we have two formulas. One is x plus y the whole square, another one is x minus y the whole square. Okay, seeing the middle term or checking the middle term, you will like finalize whether it is a minus b the whole square or a plus b the whole square. Here all the terms, especially the middle term, is positive, so we can reduce it as x plus y the whole square format. In place of x you have x as it is, in place of y you have 1. Okay, that can be written as x plus 1 the whole square. Now simplify these two. You got it as minus 1 plus 2, that is plus 1. So we have simplified and expressed as the whole square format the equation whatever they have given. Now rewriting this, integral dx by square root of that x square plus 2x plus 2 can be written as x plus 1 the whole square plus 1, I can write it as 1 square. Anyway, it will not going to change, right? And now this is of the form integral dx by root of x square plus a square. Again, log of x plus root of x square plus a square plus c. This is the required formula. And in place of x, we have x plus 1. In place of a, you have 1. It is a straight away substitution part. So you can write it as log of x plus 1, because in place of x we have x plus 1, plus root of x plus 1 the whole square plus 1 square plus c. This is the required answer. Okay, or you can write it as the equation form. So log of x plus 1 plus root of x plus 1 the whole square plus 1 square only. We have taken that x square plus 2x plus 2, yeah, that you can write it here plus c. Any doubt in this? Any doubt? I'll just give 2 minutes time. Go through this and let me know if you have any doubt. Remaining questions we will work out. So we have 23 questions. So we have worked out till 10th question. Remaining questions we will work out in the next class. So if you need, post your convenient timings in the comment box. I can schedule the classes according to that also. Okay. Whatever doubt or whatever you need, post it in the comment section. And thank you everyone, those who have joined now. As usual, like I'm not expecting, I didn't expect that these many children will join, and these classes are for your purpose only. If you feel any topic, particular topic is difficult, post that, I will reteach again. Or if you need any clarities or any topics, whatever it is, post it in the comment section. So we'll meet in the next live class. Thank you.